thing we're going to talk about is inverse matrices. And so an inverse matrix, it has all these cool things that it can do, and we'll talk about one of the cool things in the next lesson, but right now we're just concerned about what is an inverse, how do we find it, and this one property here, two matrices are inverses of each other if when you multiply them together, either direction, A times B and B times A, either way you get this thing called the identity matrix.
And the identity matrix is actually really cool because all it is ones and zeros.
Right. And so what happens is you have ones in a diagonal going from top left to bottom right.
Right.
So if we wanted a 3x3 identity matrix, it has to be square.
It's got to be square. If it's not square, can't do it.
Then you have ones in the diagonal and zeros everywhere else. So this would be the identity matrix for a 3x3 matrix. And by the way, we didn't mention earlier, but a square matrix is a matrix where it is a square. Like, what does that even mean to have a square? It means the
same
rows
width,
and columns
same
are
height.
the same.
Yep.
So if somebody asks you, hey, is that a square matrix? Now you can
tell them. You can be like, hey,
tell 'em.
hey, this is what a square matrix is, guys.
All right, so let's do A times B. Get our multiplication practice on. We're trying to prove these are inverses, so that's our steps, is A times B, see what we get. It should be the identity, and then B times A, see what we get. So this row, this column. So that's
3, 1
times 1
negative 2
plus negative 2
times 1
times 1. Okay. Row, column. So that'll be the spot here. 3 times 2 plus
negative 2 times 3.
Times 3.
And then you can fill in the pattern, or you could do rows, columns, whatever is most comfortable for you.
Absolutely.
And by the way, these take just a little bit of time. Please do not rush through these. Please do not try and save paper on these. Just
do it.
Just do it. Take your time, relax, write it all out. You'll be a better person, a better human being.
So when we work this out, 3 times 1 plus negative 2 times 1 is 1. 3 times 2 plus negative 2 times 3, that's 6 minus 6, which is 0. Negative 1 plus 1 is 0, and then this is negative 2 plus 3, which is 1. That is the identity matrix.
That's the identity matrix.
Let's see if we can do this the other way around now.
And if we can do it the other way around, life will be good.
1 times 3 plus
That's my cord. I left your cord in there. I didn't know if you needed
-2.
it.
That's this row and this column.
Sorry, I looked up. I didn't see where you were
3. At. Sorry, this is negative 1 right there. 2 times negative 1. And then
1, 2.
this row, this column. So
I'm thinking maybe you should have written these out again.
Maybe I should have, but it's too late now.
It's all over but the crying. Well, we can fill in the pattern here. This is definitely a fill in the pattern part.
Okay, so we have 1, 2, 1, 3.
So
1, 3.
Yep.
And then 3.
And then
negative 1. And then we've got 1, 2.
1, 3.
1, 3.
And then negative 2. There we go. Then we're not all cluttered up there. And 1. Okay, there we go.
Okay, this gives us 1.
3 minus 2 is 1.
This gives us 0.
2 minus 2 is 0.
This gives us 0.
0.
This gives us 1.
Boom. So those are inverses.
Yes.
All right.
We proved it. All right, now finding an inverse for yourself, we do this formula right here. And we represent an inverse by putting a negative 1 out by matrix. That exponent means inverse, just like it always has.
It doesn't necessarily mean to the negative 1 power, though. Not with a matrix. It's not a matrix to the negative 1 power. It's an inverse on the matrix.
Okay. So,
because if you put a number to a negative 1 power, you're saying 1 over that.
Well, that doesn't even make sense to put 1 over a matrix.
Right, that's what I'm saying.
Okay.
Yeah.
Okay, then I'm with you. So we do 1 over AD minus BC, and this is something we're about to talk about called the determinant, actually. It's these diagonals subtracted. So that's 6 times 1 minus 2 times 3. And I might have put that in the wrong order, but that's what matters is the first column, or the first diagonal first, the second one second. And then this is a tricky part. You put D, which is 1 negative B, so that switches to negative, negative C, so that switches to negative, and then A. So what happens is you're switching the
Swap
diagonal
those,
and you make the other
negative
way
those.
negative. So this is 6 minus 6. Oh no, that gives us a 0 on the bottom. What that means, see how it says find it if it has one or state it does not exist? This one
is
does
the D&E.
not exist. If it did exist, we would have gotten something like 1/3
or -2
or something, and we would have had to distribute it into our matrix.
Right.
But this one does not exist.
D&E.